For question 18, express this fraction in partial fractions form. So for these fractions, first we have to identify it is proper fractions, where we can see numerator is a quadratic, denominator also a quadratic. So when they are same ranking here, same quadratic divided by quadratic, means this is an improper fractions. So for partial fraction, it only applicable for proper fraction. For this improper fraction, we need to go long divisions before we get the partial fractions. So we are taking the polynomial x squared divide by its divisor here, x squared minus 2x minus 3. So what we need a multiplier here is 1. And we will have a remainder of 2x plus 3. So from here, our improper fraction, where our polynomial divide with our divisor here, improper fraction, equals to our quotient, and then remainder is 2x plus 3 over the divisor here, x squared minus 2x plus 3. So only this proper fraction, the remainder part here, will undergo change to partial fractions. So we will take this part and start doing our partial fractions. So in order to start our partial fraction, our denominator, so our divisor there is have to be in factor form. So this is our factor. So we will start our partial fraction for our proper fraction, which is this part. Take these proper fractions and make sure we are using their factor, which is x plus 1 and x minus 3, in order to split out our partial fractions. So partially we have one factor is x plus 1, another factor is x minus 3. So that will be our step for doing partial fraction. First, make sure it is proper. Second, we'll make sure the denominator part, the divisor here, will be in factor form. Then only we can express in partial fraction correctly. So when we have denominator as linear, numerator here will be a smaller ranking, it will be a constant. So when denominator is a factor in linear, then numerator here will be a constant. So after expressing this proper fraction into a partial fractions, we are going to solve this unknown AB. So we have two unknown here. We build out our equation first. For numerator part, the A should be times with x minus 3 factor and B should be times with x plus 1 factor. So from here, we can solve for A and B. So we have two unknown, we have to let it 2 times. So we will let it, the x equals to 3. As we take the roots, it will be easier for us to get the unknown AB. Another roots here is negative 1. So we can see our factor here, x is 3, x is negative 1. We can get the AB directly. So when we substitute 3 here, it will be 6 plus 3, 9. And then 3 in the factor here becomes 0. It will become 4b. So we can get our b as 9 over 4. So again, we substitute for x, negative 1. Here will become 1. Here will become negative 4. Okay. And then negative 1, when you put in back into its factor, it becomes zeros. So a will become negative 1 over 4. After we done our a and b, we have to rewrite it into our partial fraction form. So we have to go back to the original questions here, where it is equals to 2x plus 3, our partial fractions, x plus 1 minus 3, it will equals to, for A, negative 1 over 4. So 4 is at denominator part. Meanwhile, for B, it will be 9 over 4. So 4 at denominator part together with x minus 3. So this only fulfill the remainder part. The remainder part here. So our question have to go back to the original. Therefore, finally, the original when we doing x squared divided by this x squared minus 2x minus 3, it will equals, we have to write it up completely together with the quotient 1 plus the remainder part, which is this. So negative 1 over 4 will become negative. Okay, so we have to put back our partial fraction form into the original question together with its quotients. So from here, that will be our first concept where we only using the proper fraction to go partial fraction. So that's why it needs a long division here. So that will be our first concept to get to this part. And then we express the proper fraction in partial fraction in terms of AB. And then we're going to let it to find out our A and B. So this is the concept of let, this is the concept of answer. Finally, we answer it in answer back in partial fraction form.